Hey guys, welcome back to the RCA R359 field test television restoration project. Been a little while since I did an update, but I finally have a positive development. You may recall I have been trying to source a replacement socket. One of these sockets for the rectifier tube on the power supply had failed. Generally, all the sockets and tube sockets used in this set are not all that robust. They're made from a couple layers of phenolic material with rather robust pins, and the phenolic material tends to crack and start failing from the force of inserting and removing tubes. Well, at the time when it failed, I thought, well, I'll just remove it and surely I can find a replacement. After all, 4-pin tubes were really common back then. Type 80 rectifiers, for example, or 45 output tubes. Every radio from the 30s basically had a 4-pin socket. Well, I quickly found out that yes, that is true, but the sockets used in basically everything don't fit. The hole diameter here and the spacing on these mounting pins is a little bit smaller than what you would commonly find. Okay, fine. I set up searches on eBay, went to swap meets, went to the early television convention and looked through a bunch of stuff thinking surely I'll find something. Did not. Thought, hey, RCA radios from the same period must have used a socket like this. Not the case. So I was left with a few options. One, fabricate a new one and salvage the old pins and build up one from scratch. Still a possibility, but not something I particularly want to endeavor doing because it's riveted together and it would be a bit of effort. So I thought, well, I'll go out and buy some and I'll make them work. So this is what I showed in an earlier video. I thought I'd mount it from the top, mount it from the bottom, file it down a little bit so it'd fit, but it just was not happy with any of it. So I mounted it from below because it's beveled and too big. It doesn't sit flush. If I go from the top, it doesn't fit unless I file it down. And if I file it down, then it's loose. And this chassis material is about double the normal thickness, so the retaining ring, snap ring doesn't want to fit right. Yeah, I could enlarge this slot around the outside. Basically, I was just getting frustrated. So I just put it to rest for a little while and just continued to search. Somebody recommended ceramic, so I picked up a modern ceramic one, and yeah, of course, it's too big. You can't easily file this down, and the mounting holes for the sleeve don't really line up too well. Anyways, plus it's bright white, which does not at all match that. Okay, cool. Hey, I found a black one that's round. No dimensions given for the ceramic or this. These are modern ones made in China, but I figured, hey, I'll give it a shot. Nope, same problem. But I thought, hey, at least I could file this down. It's plastic. I could probably make this work. But I like the type. See, it's not beveled like that. And if I mounted it from below, I was thinking, yeah, that's not too bad, but it's black. The original is phenolic. Well, while looking for that, I finally stumbled across this. Now, part of the key to that was finding out what this part number is, which I'll show you in a moment. I don't recall what it is right now, but this is a vintage Amphenol socket. And I've been finding that's the key to a lot of this stuff is when you're searching for these parts is to know what is it called. Might be stamped on here. No, so I was just searching for 4-pin socket, but if you get more specific, you can narrow it down a little bit, and it turns out that the diameter of this phenolic material fits perfectly. And the mounting holes are pretty darn close. If I used a smaller diameter screw, like a number 4, I would probably just fit in there without me having to do anything. But if I just take a rat tail file and enlarge this, notice on these they use slots so they can accommodate a bit of a range, whereas this is just a hole. But if I elongate that hole just a little bit, it'll fit just fine. On the top side, it looks pretty darn good. On the bottom side, obviously they're very different. Which got me thinking, well, Do I want them to match, because I ordered up 2 of these, and replace both of them, even though this one is still intact? Or, in the interest of preserving history, should I not replace something that doesn't have to be replaced to save the originality, versus my OCD wanting me to have them matched? No, I don't really have OCD, but it is nice to have matching shiny new parts, I think. But for the time being, I'll leave the intact original, and I'll use one new one. Hey, and who knows, maybe eventually I'll find another one of these and I'll replace it. The main point of all of this is I do not want to modify this in any way, shape, or form, so it could always be restored to the original if I found a perfect socket or fabricated a new one. Alright, so what's it look like from the other side? Well, on the top, there's the original, and you can see it's got some damage too, so that's why I was at least considering replacing it as well. And there's the new one. So no, of course it don't look the same. But also, of course, once the tubes are in the socket, you can't see the sockets anyways. And as far as mounting it, I will use some little cap head screws. Could possibly use rivets, but for now, let's start moving forward with this project. So, as I say, all the major pieces are in place, so we can start putting this thing back together. I repaired the damaged Michaelex deck for the high voltage tubes, which goes in here. We are well on our way to having a rebuilt high voltage transformer that would go in this area. We have started to do some work with the high voltage filter caps that go in that area. I have the material to build a new high voltage bleeder board that goes in there, and I have wire to replace cloth and rubber coated wire as needed. Now, one thing I also want to do sooner than later is the main power transformer. I want to tinker with that a little bit. I've done continuity checks on the filter chokes and the windings on the main power transformer, which sits down in here, but I haven't applied power to it yet. So I want to trace out the power wires going to the primary, isolate the secondary wires, and apply power to it. And put some loads on those secondaries, maybe light up some tube filaments. I want to find out sooner than later, is there anything wrong with it? Even if I do continuity checks, there could be some leakage between windings. That would be obviously a problem. It's not an off-the-shelf part. If there was any problem with it, yeah, well, let's assume that it's okay for now. But if it's not, I will obviously need to address that. I gotta say too, not that I ever lost any motivation for this project, but getting the set working at the Early Television Museum during the convention was really awesome, and makes me want to dive into this set even more. Also, there is another development I will show you on my computer. I'm scrolling here through my written account of this project on the Antique Radio Forum, and there are some photos from that Early Television convention and the museum set. While poking around in it and getting it to work, I discovered something about one of the tubes in it. The 2x2 high voltage rectifier looked a little different. Another collector pointed out to me that this is the early type of 879, also known as a 2x2 type tube, that has something called I think it's a ribbon fan or ribbon filament. Looks rather different from your run-of-the-mill 2x2s. In fact, I have a number of 2x2s, and I've seen plenty of them for sale, and none of them look quite like this. Turns out this is the original style, and it's what would have originally been in my set, but I don't have one, so I've been on the lookout for one. Now, there's no shortage of these tubes on eBay. They are not rare by any means, and few people have any use for them. They use them in some early oscilloscopes Of course, these pre-war tubes. There you get a new old stock one for $2. But notice how they all look. They have this bell on top of the filament up inside, just like a 1B3 rectifier tube you're probably more familiar with. Well, I set up a search for the past few weeks, hoping to find one of those early style type 2x2s or 879s, and today I finally got a hit. Found it at Vacuum Tubes Inc. I think that's Jim Cross that runs that site. He says it tests strong. I don't think it might not be new old stock, but it's a good tube for sure. Looks to be in really good condition. And in this photo you can really see that unusual type filament there. And the plate is just, well, it's like a plate sitting above the filament. Rather delicate structure. So now I have to worry that it survives the journey from Florida to Chicago. I have not secured it yet, so I was a little on the fence about even talking about it before it's in my hands and tested good, but I was excited to find it and I wanted to share the news with you. Now, as for that tube socket, RF Parts. It's a website I had heard of before but never really dove into deep. They have some interesting stuff. Somewhat similar to Surplus Sales of Nebraska. And here is that socket. It's an SK4P Amphenol. The site caters more to amplifier type products, vintage tube amps. So they have the big stuff, the big iron stuff, and I'll give you some idea. So if you want to roll your own tube-based transmitter from scratch, this place is your friend. Not the kind of stuff I use every day, but there's some interesting stuff, even just to look at. Some of it also gets crazy expensive, as you might imagine. Alrighty, so I need to clear off couple projects from the workbench. I'm going to get the power supply back up there and really start going to town on it. A small package just arrived from Vacuum Tubes Inc. Should be my lovely early style 879 rectifier tube. Let's see if it survived the journey. Yeah, looks like it did. Looks like it did. So it's not something you see every day. So to remind you, this is the high voltage rectifier tube for the Focus, which is about 1,500 volts or so. So that would be the filament there. Don't know if it has a coating or filament slash cathode, and then the plates on the top. So although it has 4 pins, only 2 of them actually go to anything. The filament and the cathode are one and the same. And there's your plate, and just a gap in between. It is a diode. It's a simple tube as you can make. So why is it shaped like this? Well, high voltage rectifier, you don't want any arcing inside, so you space the plate far away from the filament, but you can't go too far, otherwise you won't get the electrons getting across the gap. But if you get too close, it gets short. So they were tinkering with the design, and it evolved. And if you go down the rabbit hole like I did into the 879/2x2 and then 2x2A, there are tube collectors who've posted collections, and there's a myriad of designs as these changed over the years. Eventually things like the 1B3 just completely supplanted them. This is the very, very early incarnation, and there is a support down the middle. Now I did see a photo online of one of these lit up. It wasn't quite what I expected, so I don't think the 2 outer ones go to the filament juice. I think the center goes to one side of the filament juice, and the 2 outers are actually connected together, and it looks like the two halves glow like they're in parallel. Here we go, found it on the internet, and okay, yeah, 4-pin base, 2 of the pins are unused, the other 2 are just the heater, which is tied to the cathode, one and the same, and it's not a center tap filament, so yeah, it just runs on 2.5 volts and 1.75 amps, and that is that. Alright, so let's double check the tube tester here. 2.5 JR and all the rest zeros, bias 0, English 87. First I'm going to check a conventional newer type 2x2. You can see how different the structure is, a big bell up top, and you really can't see the filament that goes up inside. Let's pop that guy in, it up. And the curious thing about this when you test it is that you press P5, which is gas test. Normally it's just P3, which is a rectifier, or P1 for low power diodes like a 6AL5, but this says push F5. Generally testing high voltage rectifiers in a tube tester, it doesn't really work that well because it's not applying anywhere near the normal operating voltages they'd be at. But let's see what happens with this guy. So F5, okay, that's good. Can you actually even see anything glowing in this guy? And see a little bit of the filament there. And that's in the good. Okay. Well, that's one of the charms with this style, from what I saw of an example online, is that the filament's exposed, so you get to see it glowing. Of course, it's in a box that's sealed up, so normally you'd never see it anyways. But if it is out in the open, it looks kind of cool, I think. So let's hook that up. Power back on. Double check the line. Oh yeah, filament's glowing. I'll unmount the camera to give you guys a better peek at it. It's a bit brighter than the photo I saw of one online, and it is just slightly dimmer in the middle where that support is, but now I'm thinking that support might just be drawing away some of the heat. I don't think it's actually has anything to do with how it's hooked up electrically. But there you go. So, is it actually any good? Let's hit F5. Yeah, okay, well, it's in the green, but I don't know if you guys can see that. It is glowing slightly bluish purplish inside. So it does appear the tube is a little gassy. Here's the thing though, the getter is fresh. Looks really good, so if I let this run a while, it may scrub out some residual air that got inside. And it is testing in the green. I mean, it's not, let me sugarcoat it, that's not great. I'm not thrilled to see that by any means. But I'm not going to completely write off the tube yet. Now, I have been breadboarding the power supply. So, this is the tube that hooks up to that neon sign transformer secondary I've been winding. Although the high voltage rectifier transformer hooks up to is on the main chassis. But what I'm getting at is I can rig this up somewhat. I should be able to rig this up so that I can actually run it with real operating conditions and see how it goes. For now, I'm going to let this run a little while on the tester and see if that getter maybe can scrub out some of that air. Let's see where the reading's at. So, about 3 ticks above 1500. 2 ticks. See if that changes over time. Yeah, well, maybe it's just all wishful thinking. After about 15 minutes or so, it's testing now, sort of in the question mark region, and it is still glowing somewhat. So, yeah, I don't think this is going to work out. Well, at least we got to see one. I'll try it in the real thing, but I got a feeling that it could very well arc inside. But oh well, such is life when you're trying to work with components that are 90 plus years old. I let it sit for a couple hours, and things didn't change really to any noticeable degree. It's still kind of in the question mark region. It's still a really faint bluish purplish glow, but the application in this set doesn't run anywhere near its maximum ratings. Maybe it'll work. I don't know. I'm not going to write it off yet. Could I return it and get a refund? Probably. It's a reputable tube vendor, but given its rarity, even if it was bad, it would make a nice display item to go along with the set, so I'm going to hang on to it. Meanwhile, let's move forward with this project. So when we pick up, we're going to finally start doing stuff with this. As I say, I want to isolate that power transformer, and we're going to power it up, and we're going to hook it up to a tube or two or simulated load, and check out the voltages and start wiring this thing back up, and let's move on with this project. That's it for now. Thanks for watching.